Welcome to your lecture on thermochemistry. Today we're going to be looking at the phase diagram. This is not to be confused with the phase energy diagram. The phase energy diagram is when we looked at the amount of heat or energy it went into heating up a solid, liquid, or gas and changing it from solid, liquid, or gas by melting or boiling or condensation or freezing. Now we're just looking at the states of a substance and the temperature and pressure which those states would occur, or you would change the state based on the temperature and pressure. I would suggest that you have a pencil or pen and paper for this lecture, writing down any notes that are questionable to you for understanding, clarification. Hopefully we'll answer them by the end of this lecture, but if we do not, please make sure that you see your instructor to get those questions clarified for you for better understanding before we do the assessment for this unit. All right, a couple of things you need to know about the phase diagram, and we'll point those out on the diagram itself, but there are two very important parts of the phase diagram you need to know, where one starts and the other begins. The first one is the triple point. The triple point is the temperature and pressure at which you see solid, liquid, and gas, all three phases, and they exist at the same time. They are in what we call equilibrium. Well, what is equilibrium? Equilibrium is not the same amount. When we say equilibrium, we mean the same rate of occurring. So when you look at, I think that's ing. Anyway, so when you look at the solid, liquid, and gas at that particular temperature, they are changing to solid, liquid, and gas at the same rate, not necessarily the same amount. So make sure that you understand what a triple point is. Write it down. Make sure you know it. The other term that you need to know, and the other point, critical point, is where the temperature and pressure are such that you can no longer distinguish between a liquid and gas phase. That means at this particular temperature and pressure, the liquid and the gas are so mixed and combined with each other that you can't really point out where it's just liquid and where it's just gas. This is called the critical point. So make sure you understand where the critical point is located and what the critical point means, as well, of course, as the triple point. So let's look at a diagram. This is the phase diagram. A phase diagram has a solid, liquid, and gas section to it. Solid is going to usually be where it's a cooler temperature. Gas is usually where it's a hotter temperature, and liquid is going to be somewhere in the middle. But see how they distinguish from each other. The lines you see, or the Y you see, is telling you what's going on. This line is between the solid and the liquid, because in this line, a solid can either be melted to a liquid, or the liquid can freeze to a solid along this line at different pressures and temperatures. This line is between the liquid and the gas, because it's along this line at these temperatures and pressures that liquid can boil to gas, or gas can condense to liquid. And then the last line, the tail of the Y, is between solid and gas, because the solid can sublimate into gas, and the gas can deposit or deposition itself as a solid. So those are the lines where it would occur. Now, the different temperatures and pressures are on the x-axis. This is your x-axis. And your pressure is on your y-axis. Pressure can be in atmospheres, it can be torrs, can be millimeters of mercury. All those units can respond to pressure, and we'll go into those a little bit more when you get into the gas laws. But right now, we just need to know that we have pressure and we have temperature. As the pressure changes at a particular temperature, we can actually determine what state it will be in. Again, as the pressure changes at a particular temperature, we can say it's going from one state to another. In this case, it's going through the gas state into the liquid state. We can do the same thing when it comes to pressure. Let me clear the board a little bit. There we go. At a particular pressure, if we change the temperature from one temperature to another, we simply need to see where the line falls. It goes from a solid into the liquid stage into the gaseous stage, and that's how your phases change. I can ask you at what temperature a particular process occurs. If I can tell you that at this pressure, this is going to melt, what temperature would that be? You simply come down and look at the temperature. I can tell you at a particular pressure here, boiling is going to occur. What temperature would that be? You can come down and tell me what a particular temperature is. I can do the total opposite. I can say at a particular temperature, I change the pressure. You can tell me what that state is going to be. Or at this temperature, I change the pressure from here to here. What's going to happen? It's going to go from gas to liquid and back and forth. And more importantly, I can give you a particular pressure and ask you, what is the melting point, since this is between solid and liquid, and what is the boiling point, since this is between liquid and gas. And based on that information, you can then tell me at what temperature those things occur. Okay? Once again, this is your critical point. Remember, this is where the liquid and the gas are indistinguishable from each other. The temperature is such and the pressure is such that you can't tell the difference between liquid and gas at that point. And then here is your triple point along this line. At triple point, you see both the solid, the liquid, and the gas all exist at this particular temperature and this particular pressure. So take a moment to look at that, make sure you understand it. And then we're going to review real quick and see how good you are. Okay. A, B, C, D, and E. Take a moment and see if you can't label all those. And where you see the lines, see if you can't tell me what is happening here between E and A, what is happening here between A and C, and what is happening here between E and C. When you're ready, come back and we'll check it. Okay, so A is my liquid. B is my critical point. I hope you got that. C is gas. D is triple point. Hope you got that one too. And E, of course, is solid. So what's happening between the solid and the liquid along this line? We have melting from solid to liquid, and we have freezing from liquid to solid. Along this line, we have boiling from liquid to gas, and we have condensing from gas to liquid. And along what we call the tail of the Y, we have sublimation from the solid to gas, and we have deposition from the gas back to the solid. So if you got all those right, you now know how to label this, okay? Now all I got to do is practice how to use the pressure and the temperature to determine what's going on. Here is another phase diagram. Again, the coldest part, we're going to call that the solid. The warmest part, we're going to call that the gas, and then we're going to call that a liquid. But here we actually have numbers more so with our temperature and pressure. So let's say ST, standard pressure. Standard pressure, we should know by heart, is 1 atmosphere. So at standard pressure, I want to know what the boiling and the freezing point is. So I find 1 atmosphere, which is here. Draw a line across. Right here is where the solid and liquid converge. So this would be my melting point. And so my temperature, a little bit better. There we go. It's about right here, which is what, like negative 110 degrees Celsius. And my boiling point, close. It's about 100 degrees. I give it 100 degrees Celsius. So now I know what my freezing point is, and I know what my boiling point is. Make that a negative. So at negative 110 degrees Celsius, my substance is going to freeze. And at a negative 100 degrees Celsius, my substance is going to boil. It's not water, because we know water is 0 and 100 degrees Celsius. So let's see if we can do a couple of questions on here, just for practice sake. Let's just say I'm at 10 atmospheres, and I change my temperature from 0 to negative 75. Right here. What state am I going from? Well, I'm going from 0, which is the gaseous state, into the green lane, which is the liquid state. So I'm going from a gas to a liquid. What if I start at a negative 150 for my temperature, and I change my pressure from 1 atmosphere to 100 atmospheres? What's going to happen? It's still going to stay as a solid because it stays in the blue, which is a solid area. Okay? And what if I am at 0.9 atmospheres, which is probably about right here, and I change my temperature from negative 120 or so to negative 10 or so. What's going to happen? I'm going to go from a solid. A little bit of liquid will exist, so I'm going to go through the triple point, and then I'm going to go to gas. Okay? So, look at it for a moment. Make sure you kind of understand that. All right? And I'm going to tell you one last thing. Again, standard pressure is 1 atmosphere. So if we ever ask you about the normal, we ask you at standard pressure. Remember, you need to find the 1 atmosphere. Let me go back here. Find the 1 atmosphere. Draw yourself a line straight across. And where you see the solid and liquid line, that's melting and freezing. And where you see the liquid gas, that's boiling and condensation. And those where you get your readings from. All right, now we're ready to move on to the next one. Okay, so here's the worksheet. We're not going to do all of them, and some of them don't apply to us at all. But I'm just going to look at a few of these questions and see if we can't work them on here. Okay, so first of all, where's my solid, liquid, and gas? Here's my solid, here's my liquid, and here's my gas. What is this up here that is probably like way too cold? So we're not even going to look at it. We're not even going to look at that in here. So let's look. First of all, what are the values for temperature and pressure at STP? Well, we know what standard temperature and pressure is. 0 degrees Celsius. Our pressure is 1 atmosphere. So I'm going to put 0 degrees Celsius and 1 atmosphere. That's standard temperature and pressure. Now, question is, with this substance, what is its normal freezing point? Well, its normal freezing point is going to be at 1 atmosphere. So we got to find 1 atmosphere. Draw a straight line. No straight line is not going to be perfectly straight. We're guesstimating. And it says, what is the normal freezing point? Well, the normal freezing point is going to be where the solid and liquid come together, right? So here's your normal freezing point. And if I go down, oops, go down a little better than I did that. It's just a little bit over 0. So I'd say it's like 1 degree Celsius. And the normal boiling point, like right here. Oops. There we go. And that's like 101 degrees Celsius. And if I ask for the normal melting point, well, we know melting point and freezing point are the same, so it's still going to be 1 degree Celsius. Okay? Let's look at something else. Let's look at this question. What is the phase of a substance at 0.5 atmosphere and 100 degrees Celsius? Well, here's 100 degrees Celsius. And 0.5, that's 0.1, so that's 0.5 atmosphere. Go a little bit lower. Okay, so if we go all the way across and come down, whatever we want to do, we're still going to be in the gaseous phase. So that's going to be gaseous phase. Okay. Let's look at another problem. Let me see. This doesn't apply because it doesn't go to 200. So we'll mark that out. This doesn't apply because it doesn't go to 800. Remember, we'll stop at 120. What is the condition of the triple point of this substance? Well, let's find the triple point. Remember, triple point is the point at which your solid, liquid, and gas all exist in equilibrium. Not the same amount, but we're talking about at the same rate. So here is my triple point right here. So if I go straight down, make that a little bit better. There we go. Down from there, it's like 0. So it's like 0 degrees Celsius. 0 degrees Celsius. And the pressure is a little under 0.01. So I'd say 0.009 atmospheres in pressure. So at 0 degrees Celsius and 0.009 atmospheres, we have the triple point. Okay, let me see. This is a question about 300 degrees Celsius. We don't have it because we only go up to 120. And this is 200 degrees Celsius. Oh, negative 200 degrees Celsius. Doesn't matter because we don't have that or the 200, so we don't need to look at that. But what we can look at is if this substance was at 0.75, what temperature would it melt? Well, this is 0.1, 0.7 is a little bit higher, probably about there. So let's see. All right, 0.75 melting would be a little over 0 degrees Celsius. So that would be about maybe 2 degrees Celsius. And if the substance was at 0.75, what temperature would it boil? Well, boiling is here. It's about maybe 90 degrees Celsius. Okay. At what temperature? There we go. At what temperature does the gas and liquid phases become indistinguishable? Well, what's gas and liquid phases indistinguishable? Can you remember what that's called? Take a minute. Hope you got the critical point. So the critical point would be right here. And that is going to be between 110 and 120. So I'd say about 115 degrees Celsius. And then finally, it asks, at what pressure would it be possible to find this substance in the gas, liquid, and solid phase? Remember what gas, liquid, and solid phase existing together is? It's called your triple point. So we need to find our triple point right here. And remember, we already talked about what our triple point would be. So the pressure of our triple point, right up under there, is just under 0.01, which is going to be 0.009 atmospheres. There's your pressure. All right, so look at this closely. Look at how I did this. A couple things I do want to make sure that you remember that standard pressure is always going to be 1 atmosphere. Standard temperature is always going to be at 0 degrees Celsius. So if I ask you a question about standard pressure, or ask you a question at standard temperature, or I ask you the pressure at standard temperature, whatever, make sure you remember that it's 0 for standard temperature and it's 1 atmosphere for pressure. All you do is draw a line. If I'm asking for pressure, you go to 1 atmosphere, draw a line all the way across. Where you see the solid and liquid line, that's going to be melting and freezing. Where you see the liquid and gaseous line, that's heating, boiling, and condensation. If I told you I was at standard temperature, then you find the standard temperature, go straight up, and based on the standard temperature, you would answer those questions, okay? Okay, so I hope that you got a better understanding of this. Please go back and do some of these problems over and over again. Check and see if you've labeled them correctly. Hopefully your questions have been answered that you wrote down for understanding. If not, please, please, please make sure you get with your instructor before the assessment.